So let's look at this question. We have a grid and the robot, which is denoted by the up arrow, needs to visit every square in the grid which does not contain an object. The objects are shown as black squares. Now it's asked you to complete an algorithm, and it's given you the instructions that you must use in the algorithm, and there are 5 instructions. One's duplicated. Forward distance, distance equals distance minus 1, distance equals 4, turn left, turn left. It's good to sketch out what the robot could do. There are many paths, but let's just sketch one path out. So it could start here, it could go up 4, it could turn left, it could go 4 spaces, could turn left again, go 4 spaces, turn left again, 3, turn left, 3, turn left, 2, turn left, 2, turn left, 1. So it's asked you to sort of write an algorithm which will trace the path of the robot through the grid. Now it's given you here some of these some statements, and it's asked you to fill in other statements, and it's given you the set of statements here and asked you to use the statements only once. It's a little bit of trial and error. Now you know that in a program or an algorithm you sort of start off by initializing things. So therefore perhaps we'll have distance equals 4. So we'll put distance equals 4 there. So that's used. Then you know you've got a while statement here. Within a while statement, if it's whilst distance is greater than 0, so therefore you probably increment or decrement the distance. So here is the statement which is decrementing the distance, meaning subtracting. Distance equals distance minus 1. Distance equals distance minus 1 there. So there's 2 of these statements are taken care of, or rather 2 here, this one and that one. Then what distance is greater than 0? Perhaps it's you go forward, so the robot goes forward here. So we'll put the forward command here, forward distance, and then you're left with turn left, and we put them in here. Then what you do, you've got your algorithm that you've proposed and you sketch it, or rather you trace it to see whether or not it is sensible. Let us look to see if what we have written is sensible. So it's a bit of a guesswork, a bit of a trial and error. But here, distance equals 4, well it does start on here. 1, 2, 3, 4, it's 4 away from there. Whilst distance is greater than 0, distance is 4, so it is forward distance. So it traverses up, 1, 2, 3, 4. Then what does it do? It turns left. So it turns left and it remains on this square there. And then what does it do? It says forward distance. So it turns left and it goes 4. 1, 2, 3, 4. Ends on this square here. And then if you look here, it says turn left. It turns left and it remains on this square. And then it goes down 1. And then distance equals distance minus 1. So distance equals distance minus 1. End while, and it goes round again. So distance is now 3. It's greater than 0, so it forward distance there. So it goes 1, 2, 3, turn left, and then it goes 3, 1, 2, 3, and then its distance equals distance minus 1, so it becomes 2, and you go around the loop again. And what does it say here? Forward distance 1, 2, turn left, remain on the square, goes 1, 2, and then distance equals distance minus 1, so distance becomes 1. So forward 1 goes here, turn left, and it goes here. And then distance equals distance minus 1, it becomes 0. So whilst distance is greater than 0, distance is now 0, so it doesn't execute the loop and it exits. So this algorithm here, if you trace it, you will see that you do